Oh yeah. Gotta take the old Volvo over to the lab, Professor.
Yeah. Professor.
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 Oh, Matt, you just got caught.
What? Oh, economy mode?
You're in economy mode.
No.
Are you kidding me?
Oh my god.
Our testing of the chassis consists of like multiple phases, and this is just our material phase where we're testing the samples. So Matt, we're going to the lab and we are going to get that going, but we have a lot of other stuff to do. We got to do sim testing on the entire chassis, so we know where our weak points are, and then we wrap it up with actually strain gauging the actual chassis under driving conditions, and then we know where we're at and see what kind of loads we're going to see on the road, and then based on the data that we get through these samples, we'll know if it's good to go. All right, so what are we going to the lab for?
Filming the setup of another sample, make sure that we're getting the data that we need before we really just kind of set up like a full kind of test matrix setup.
You heard it here first.
Now we have the extensometer on our extensometer calibrator. This extensometer has a gauge length of 1/2 inch, and this pin establishes 0 at 1/2 inch. We set our extensometer at 0 here, set our excitation to 5.996, and then manually 0 it to make sure that the reading is 0. So now we're kind of at an equilibrium position, so we can now move forward with the calibration. So we'll open it up in tension, so we're spreading it apart.
Live. Does it fit?
Which direction you want it, like on the back side here? On the flat back side? Well,
Is it gonna fit?
I think it might. Now the only problem is, right, this sample is stretched a little. You think we'll have?
Oh shit, yeah.
Okay.
That's the smallest it gets. It only gets bigger.
Well, it gets bigger as it pulls, but what I meant was this sample stretched a little, so it isn't going to do that much. Awesome. All right, so we are putting radiuses on the corners of the sample, and then we are going to be polishing the machine marks out, because any sharp corner or dent will create a stress point that the sample will break from, and that doesn't really give us the data we want. We want the material itself and not any kind of odd dent or stress point. So what'll start to happen is you'll see it start to drift as it tries to shoot for 0 load.
That's the old sample?
Yep. This is the trial one we ran. So you can see it's deformed in the middle. We were testing to make sure the sample was going to break or deform in the middle and not really at other points like the holes. We were making sure that was going to work correctly. Once the fans come on, it'll be warm enough. We're going to have to scratch it to 252. Just do set point.
999. Displacement. It's smaller and then smaller, and eventually it stabilizes. It stabilizes all the way out, and then
Pin up gauge, baby.
he's got his hands on the wrong side.
What do you mean I got my hands on the wrong side? All right, perfect. No, hold on. This is gonna work. 150 pounds anyway. At least, should be.
We'll just
Right, so she's running.
Oh yeah. I don't know how to make that funny.
Not asking you to make it funny. Tell me if it's running or not.
Yes.
All right. So now we wait.
Yeah, it takes a while.